Experiments in modern rocketry began in the early 1900s, primarily in the United States, Germany, and Russia. American rocket pioneer Robert Goddard made significant advances in liquid-fueled rockets and gyroscopic guidance systems in the 1920s and 1930s, but his work received little attention. During World War II, the Germans made use of early rocketry research and developed the first modern ballistic missile, the deadly V-2. The V-2, with a range of 195 miles, or 313 kilometers, demonstrated significant advances in rocketry technology. After the end of World War II, Wernher von Braun and well over 100 German rocket scientists joined American scientists here in the U.S. to develop new rocket technology. On July 24, 1950, the first rocket launch from Cape Canaveral, designated Bumper Number 8, occurred at Complex 3, utilizing a German V-2 first stage and a United States WAC Corporal second stage. On October 4, 1957, the Soviet Union launched the first Earth-orbiting satellite, Sputnik 1. The space race between the Soviet Union and the United States had begun. Prior to the launch of Sputnik, von Braun told President Eisenhower that an existing military rocket, the Redstone, could place a satellite in orbit. The president disapproved, saying the non-weapon Vanguard rocket would launch the first United States satellite because space should be used for peace, and the Redstone was built for war. The first official United States attempt to launch a satellite occurred on December 6, 1957, from Cape Canaveral's Launchpad 18A. This launch ended quickly when the Vanguard booster blew up 1 second after launch. After this failure, President Eisenhower gave his approval to use a modified Redstone military rocket to launch the first U.S. satellite. Under the direction of Wernher von Braun, a Juno 1 rocket, comprised of a Jupiter C with operational second, third, and fourth stage motors, carried Explorer 1 successfully into orbit. The launch occurred at 10:48 p.m. on January 31, 1958, from Launchpad 26A, and was controlled from the nearby Blockhouse. Some of the original hardware used to support launch operations in Blockhouse 26 remain today. Firing Room 26B, one of the 2 firing rooms originally operating in the Blockhouse, looks similar to the way it did in the late 1950s. Equipment similar to this computer was used to perform flight computations during that same period. Far more complex computer hardware now fits in the palm of your hand, but in 1958 this was state-of-the-art. And why is there a scale to measure weights of thousands of pounds here in the Blockhouse? Very simple, to weigh the missile. This scale provided the data engineers needed to calculate how much of the continuously evaporating liquid oxygen was in the missile's oxidizer tanks. The correct amount of oxygen and propellant is critical to achieve the required missile thrust. In the center of the firing room of Blockhouse 26 is the console from which the final launch command is given. Activating the manually operated switch under the red protective guard gave the final electrical command to begin the missile's automatic firing sequence for launch. In all, there were 36 launches from Complex 26, including launches of monkeys Abel, Baker, and Gordo, who helped pave the way for the historic flight of Alan Shepard, America's first astronaut. The Soviet Union, however, sent the first human into orbit, Yuri Gagarin, on April 12, 1961. The United States was not far behind. On May 5, 1961, Alan Shepard became the first American to travel into space. Shepard soared aboard a Mercury Redstone rocket from Pad 5 at Launch Complex 5-6 in a suborbital flight. Located south of Blockhouse 26 on the museum grounds, it is almost identical to Complex 26. The development of reliable launch vehicles was not without its problems. This was a very new and complex endeavor. Through our failures and successes, we learned how to design, build, and maintain a reliable launch capability that will carry us to our destiny. The pioneering work at Launch Complexes 26 and 56, both a part of the U.S. Air Force Space and Missile Museum here at Cape Canaveral, helped pave the way for all that followed. In the centuries ahead, when we go boldly where no one has gone before, this monument to the birth of America's space program will remain here, ever pointing the way.